Alright, we're going to do a little mixed practice on negative exponents and powers of 0. So I've got some problems that I thought about that are going to help you with your homework and your first quiz. So it's very important that you work through these with me and keep copies of them. You can put them right on the back of your note packet or staple them to the packet. So let's look at this first problem. 3x to the negative 4. And your directions are rewrite with only positive exponents. Okay? 3x to the negative 4. Right, first let's be clear on this. The negative 4, this power, this exponent, is only for the x. It's not on the 3. There's no parentheses surrounding the 3 and the x telling you to put it on both of them. So it only belongs to x. And we learned the rule in the last video that when we have a base to a negative exponent, if we move it to the opposite part of a fraction, then we can call it positive. So I like to think of this as a party. 3 and x to the negative 4 have gone to a party, and they're upstairs, because I can always put anything over 1. Now, x has a bad attitude. He has a negative exponent. I call that a bad attitude. So 3 says to x, you know what, you can just go downstairs, because I don't like your attitude. So what happens is x to the negative 4th goes downstairs, 3 stays upstairs, and when x to the negative 4th gets downstairs, we have 1 down there, times, he gets a positive attitude. When we move the base with the negative exponent to the other part of the fraction, down if it's up, up if it's down, the exponent becomes positive. Now I really don't need this 1 times it there. The 1 can just go away, because timesing by 1 doesn't do anything, and I get 3x to the positive 4. So we started with this, 3x to the negative 4, and we ended up with this. These two expressions are equivalent, but this one's easier to understand because when I put a number in where x is, it's easier to figure out that that number times itself 4 times. Here it's hard to understand what it means to raise a number to the negative 4 power. So let's say somebody gives us a number for x. Let's say somebody tells us x is 2. So then we could evaluate this expression very easily. 3 over 2 to the 4th. I'm putting it 2 where x is. And I can do 2 times 2 times 2 times 2 in my head. 2 times 2 is 4, times 2 is 8, times 2 more is 16. And I have simplified this expression without having to use a calculator and typing 3 times 2 to the negative 4 in my calculator. Alright, the next example. 2 times 8 to the negative 2 over b. Okay, we're going to that party again. We already have our upstairs and our downstairs. Who's at the party? 2, 8 to the negative 2, and b. These two are upstairs, he's downstairs. Alright, 2 looks at a and says, whoa, you got a negative attitude. You have a negative exponent. Remember, that negative exponent is not on the 2, it's only on the a. So what does 2 say to a? Hey, you get downstairs. Go downstairs. Alright, so 2 stays upstairs. B is still downstairs. He's downstairs. And a squared comes down to join him. And as I said, the negative exponent, once it gets downstairs, becomes positive. His attitude becomes positive downstairs. So look at what changed from here to here. All we did was move the base a with its exponent downstairs. Boom. 2 stayed where it was. B stayed where he was. A squared goes downstairs. A to the negative 2 goes downstairs and becomes a positive exponent on the a. That one's done until somebody tells us what a and b are. Alright, let's look at one more. You know what, I'm going to change this one. No, let's leave it alone. Okay. Alright, we got a lot of party goers now. We've got 5 at the party, x, y to the negative 3, and x to the negative 2 downstairs. So who's got to move? Well, y's got a negative attitude, but oh, so does x downstairs. So 5 stays where he's at. He doesn't even have an exponent. This x doesn't have an exponent. Oh, wait a second, it does have an exponent. Remember, its exponent is 1, because we're going to need that when we simplify it. When a letter does not have an exponent, or a number doesn't have an exponent, its exponent is 1. We won't need the 1 on the 5. Now, y to the negative third power has to go downstairs and get a positive attitude, or a positive exponent. So he moves downstairs. Oh, meanwhile, x squared, x to the negative 2, needs to move upstairs. And when he does, he gets a positive attitude. The exponent becomes positive. So again, y to the negative 3 went down, x to the negative 2 went up, and this is what we get. We have one more step on this one because these two can be combined so that we have 5 and then x times x times x, or add the exponents. 5x to the third power over y to the third power. And all that becomes this. One last example. This one's going to be really quick. What if I had something like this? 10a to the negative 5 times 2a squared times 3a to the third power. Alright, remember, all the numbers can get multiplied together first because there's timesing everywhere. There's multiplication everywhere. So you can multiply all the numbers. So I can do 10 times 2 times 3. And then multiply all the letters. Times a to the negative 5 times a squared times a to the third power. 10 times 2 is 20. 20 times 3 is 60. Now remember, when multiplying like bases, these are all a's, my shortcut is to just add the exponents. And it's a good thing we have that rule, because otherwise I don't understand what a to the negative fifth power is. So let's add up these exponents. Negative 5 plus 2 plus 3. I think that's going to make 0, but let's double check it. Negative 5 plus 2 plus 3. Oops, I got to clear my calculator. Negative 5 plus 2 plus 3. Well, come on, calculator, clear. Okay, and indeed I get 0. All of these exponents add up to 0, so I get times a to the 0 power. But wait a second, we've got another rule. Anything to the power of 0, whoops, there it is, anything to the power of 0 equals 1. In fact, a variable to the 0 power is 1. Not a to the 1, just 1. We're assuming that that a is not 0 itself. So if I have 60 times a to the 0 power, what I really just have is 60 times 1. This is just the number 1. And so my final answer is just 60. All of this boiled down to that. Isn't it crazy?